An exception is a situation that arises while a program is being executed, during which there is no point to continue the normal program flow. SAP Web AS 6.10 introduced a new ABAP objects exception concept that exists parallel to the existing concept based on System Sub RC. Exceptions and exception handling are now based on classes. This new ABAP object exception concept enhanced the classic way of handling exception using System Sub RC. In the new exception concept, an exception is represented by an exception object. An exception object is an instance of an exception class. The attribute values of the exception object contain information about the respective error situation. Raising a class-based exception normally means instantiating an exception class and setting the attributes. Handling a class-based exception involves evaluating the exception object and its attribute values. Class-based exceptions are raised either by the raise exception statement or by the runtime environment. You can catch and handle class-based exceptions with the try, catch, and try structure.
You can define your own exception classes, but the system already includes a range of predefined exception classes, particularly for exceptions in the runtime environment. You usually create exception classes globally in the class builder, but you can also define local exception classes within a program or global class. The names of global exception classes always start with namespace CX_. Those global exception classes that the runtime environment uses start with CX_SY_. SAP recommends that you start the names of local exception classes with LCX_. The get_source_position method returns the name of the main program or include program, and also the line number in the source code where the exception occurs. The get_text method returns an exception text in the form of a string. This method is not defined in CX_root directly, but in interface if_message, which is implemented by CX_root.
You can only handle an exception if the statement that raised it is enclosed inside a try-and-try control structure. You can handle the exception using the catch statement in the try-and-try structure. The try block contains the statements for which the exceptions need to be handled. A catch block contains the exception handler, which is executed if a specified exception has occurred in the associated try block. Like all control structures in ABAP objects, you can nest try-and-try structures to any depth. In particular, the try block, the catch block, and the cleanup block can contain complete try-and-try structures themselves. If a try-and-try structure contains a cleanup block, this block is executed when the try-and-try structure is exited because the system cannot find a handler within the try-and-try structure itself, but instead in a surrounding try-and-try structure or in a calling program.
The figure shows an example of syntax for handling predefined exceptions. To analyze the exception object in an exception handler, use the catch statement in the form catch into. You have to specify a suitably typed object reference after the optional addition into. The reference can be a reference either to the exception class itself or to any of its superclasses. Just before the system executes catch block, the system fills the reference variable so that it points to the exception object describing the present error situation. The ABAP keyword documentation for each statement lists the classes whose exceptions may occur when that statement is executed. If an exception is raised, the system displays name of the exception class in the exception raised field in debugging mode. If a catch block catches the exception, a success message displays. The pointer for the current statement then moves to this catch block. Two push buttons appear if an exception occurs. Use the push buttons to analyze the exception object and to navigate to the point in the source code where the exception occurred respectively. Hint: for debugger runtime performance reasons, the system does not actually create exception objects if the into addition is missing from the respective catch statement. In such cases, the last exception object push button normally does not appear. To set the ABAP debugger to always create the exception object, choose the respective option in the debugger settings.
You use Class Builder to create a global class as described in SAP Library. When you enter the name of global class, use the prefix CX_. Choose the exception class option as the class type. Define additional attributes in your exception class as necessary, for example, for generic extensions to exception tests.
Save as many exception texts as you need. When you save exception texts, you can insert attributes as parameters in the static text using the form &attribute name &. For the first text you create, always use the predefined static constant as an ID. The constant always has the same name as the exception class itself. If the raiser of the exception does not specify a text, when the exception is raised, the system uses the text with this ID. You define other IDs for all other texts. Class Builder then generates identically named static constants automatically. When the exception is raised, pass one of these constants to import parameter text ID to specify the appropriate text for the exception instance. The exception texts for global exception classes and their translations are stored in OTR in releases before SAP NWAS 6.40. Note that several texts can be assigned to a single class. You assign a text to an exception using the text ID attribute, which contains the globally unique ID of the text object in OTR in an instance at runtime. The getText method then exports this text, replaces any text parameters with the contents of the relevant attributes as required, and returns the text as a character string. Activate the exception class. The figure shows examples for statement raise exception. Raising class-based exceptions is done using the raise exception statement. There are two variants of the statement. Variants of statement raise exception type exception class exporting. This statement creates a new exception object that is an instance of the exception class. Raise exception object reference. This statement uses an existing exception object that the object reference points to. The exception object was either created directly using a createObject statement or caught in a previous catch into statement. When using the first variant, It is possible to provide values for the constructor parameters using the exporting addition. One of these parameters is used to set the exception text in the new exception object.
All exception classes offer an optional parameter, text ID, in their constructors. Use this parameter if more than one message text is available in the exception class and you do not want to raise the exception with the default text. For each text defined on the Texts tab, the class builder generates a public constant of the same name. Constants may also be inherited from the superclasses of the exception class. By default, the system raises an exception with the text that has the same name as the exception class. To raise the exception with another text, use the corresponding constant as the actual parameter for constructor parameter text ID. Note, the type of the constants and parameter text ID in the constructor is determined by whether or not the exception class was created with the WithMessage class flag. If the exception class still uses OTR texts, the constants are of type CHAR and contain a technical ID of the OTR text. If the exception class uses a message class, the constants are structures containing the name of the message class, the message number, and so on. The handling of exceptions that occur within procedures does not have to lie within the same procedure. Instead, the procedure can propagate the exception to its caller. The caller can then handle the exception or propagate it to its own caller, and so on. The highest levels to which an exception can be propagated are processing blocks without local data areas, that is, event blocks or dialog modules. These processing blocks have to handle the propagated exceptions. Otherwise, a runtime error occurs. The same is true for exceptions raised within such processing blocks. To propagate an exception from a procedure, you generally use the raising addition when you define the procedure interface. In methods of local classes and subroutines, specify the raising addition directly when you're defining the procedure. For example, methods method name raising CX underscore or form sub R name raising CX underscore. The raising addition is followed by a list of exception classes whose instances are to be propagated. In methods of global classes, enter exception classes whose instances are to be propagated into the exception table of the method in the class builder. You also need to set the exception class flag for each exception table. The process is similar for function modules. To set the indicator in Function Builder, choose the Exceptions tab. Hint: a single method, form, or function module can raise only one type of exception, that is, either class-based or conventional. Propagation of class-based exception does not require that the calling method actually handles the exception. The caller may pass the exception to its own caller even without handling it. In the example, the constructor propagates the CX underscore EXC exception raised by the get underscore tech underscore ATTR method. When the error occurs and the program raises the exception, the program flow jumps directly to the catch block in the main program. Note, if the constructor implements the optional cleanup block, the system executes this block before the catch block of the main program.
The figure shows how the standard exceptions in the runtime system are integrated into the inheritance hierarchy of the exception classes. The choice of the superclass influences the way that the syntax check and the runtime environment handle a given exception.
After an exception was caught in a catch statement, you can handle it in many different ways.
When you handle an exception in a catch block, use the retry statement to go back to the try statement of the respective try-end try structure. For example, if the cause for the exception was removed during the handling. Hint: this technique is new with release SAP NetWeaver 7.0 EHP2. In the example, the main program catches the exception that the constructor raised and propagated. After analyzing the exception object and correcting the error situation, the main program repeats the whole try block using the retry statement. Caution: you must use retry with some caution. If you do not remove the cause of the exception properly, your program will go into an infinite loop.
This technique is new with release SAP NW 7.0 EHP2. Use the resume statement to resume a program immediately after the statement that raised the exception in the source code. The handler of a given exception checks whether, at runtime, a given exception was raised and propagated, resumable or not. All exception objects provide public instance attribute is_resumable, which is set to X or space by the framework, depending on how the exception was raised and propagated. If you resume a non-resumable exception, you cause a runtime error exception class CX_SY_illegal_handler.
In the example shown in the figure, method get_tech_attr raises and propagates the exception. The constructor propagates the exception further. All raising and propagating is set up to be resumable. The main program handles the exception with catch before unwind, checks that the exception indeed is resumable, and issues the resume statement. The system resumes the execution of get_tech_attr immediately after the raise resumable exception statement is executed. Hint: in this example, you keep the context of the exception. If you do not add the before unwind addition, the system deletes the newly created instance before executing the catch block. You will not be able to resume the get_tech_attr method, and the constructor would not be executed.
raise class-based exceptions with one of the following variants of statement raise exception. Raise exception type exception underscore class exporting. This statement creates a new exception object, which is an instance of class exception underscore class. Optionally, values can be provided for the constructor using the exporting addition. Raise exception object underscore ref. The statement uses an existing exception object, namely, whichever exception object underscore ref points to. This exception object is either created directly using a create object statement or more commonly caught in a previous catch into statement and pass explicitly to the caller. In the example, the constructor catches exception cx underscore exc, which is raised by the get underscore tech underscore attr method. The constructor analyzes the exception object, performs necessary adjustments, issues a warning, and so on. The constructor then decides to pass the exception to the main program, where the exception is handled again.
After catching an exception, the program can raise a second exception and so on. An exception object becomes invalid once the program leaves the catch block. Therefore, the handler on the top level can only access the last exception object. However, you can chain exception objects, that is, you can let one exception object point to the one before, which points to the one before it, and so on. The handler of an exception may follow the chain and evaluates each exception object in the sequence. All exception classes provide a public instance attribute previous. You type the attribute with reference to cx underscore root to point to arbitrary exception objects. The constructors of all exception classes have an import parameter previous of the same type, which can be used to link an existing exception object to a new one. In the example in the figure, the constructor catches the exception that has been raised by the get underscore tech underscore attr method. After analyzing the exception, the constructor raises a new exception of a different exception class. It chains the existing exception object to the new one by passing a reference to the existing object to the constructor of the new object. As a result, attribute previous of the new exception object points to the exception object that preceded it. The main program catches the second exception and accesses to the second exception object. However, by using public attribute previous, the main program can navigate to the other exception object and analyze it. The main program can access each instance in a chain of exceptions and follow the history of the raised exceptions in the call hierarchy.